this is the video for Team Treasure Hunters Fall 2023 Senior Design Project. Today we'll be going over a senior design project, which is a new module for the MRV, the MDM Metal Detecting Module. The Modular Remote Vehicle MRV was a project started in the mid-2010s by Team Detect. It was first made as a remote control vehicle with metal detection functionality. Over the years, other senior design teams added more features. As a result, the MRV is a fully functional remote control vehicle that can perform a variety of tasks depending on what module is installed. The MRV has been used for outreach events like Discovery Day to get people interested in electrical engineering. Initially, the MRV had only a hole in the back of the module shelf that the cable fit loosely in. This required the cable to be plugged into the module manually by removing the MRV's body. Team Treasure Hunters was assigned the task of making a support for the USB cable that connects the module to the MRV's processor. The support was required to hold the USB stationary while the modules are being removed and installed. To solve the cable problem, acrylic plates were cut using the UAH Glowforge. In addition, rubber grommets were cut to support the cable. Holes were then made onto the module shelf to screw in the acrylic plate while having the rubber grommet sandwiched between the MDM and the acrylic. This design works well and gives minimal pushback on the cable. The previous body for the MRV needed to be replaced as it was old, torn, and had improper cuts. The MRV's new body was purchased at the RC Hobby Shop that had modifications made to fit the MRV's design. In order to fit this new body, we had to make modifications to the previous mounting system. Our design uses cotter pins to hold the body to the MRV. The cotter pins are held in place by rubber grommets. The rubber grommets are held to acrylic boards by more cotter pins. The first MDN had been done by Team Rhodium and was modular, but had become retired due to a current failure in the circuit. Therefore, Team Treasure Hunters were assigned to go back to the MRV's roots to make a new metal detector for the MRV. For the metal detector circuit, we decided to make a printed circuit board, PCB. The metal detector circuit is an inductive switch printed onto a 4-layer PCB with a stacked coil. The stacked coil is 4.6 inches in diameter. A reference coil is at the top and the sensing coil is at the bottom. When current is applied to the stacked coil, a magnetic field is produced. When a metal object enters the magnetic field of the sensing coil, the metal object produces an interfering magnetic field. As a result, the MDM sounds a buzzer for metal detection. Conversely, if you place a metal object on the reference coil, metal detection will not occur, or if you do both coils, then metal detection will also not occur. The stacked coil design was chosen to prevent false detections. Now let's look at the results. For the cable support, the module case is not standardized. Discovered during validation testing, the MDM's module case does not have the same USB port placement as the LiDAR module case. To remedy this problem, the acrylic plate's cutout had been increased to accommodate for both modules. As a result, when installing a module, small adjustments may be required to install each module by moving the cable. The MDM's reference and sensing coils had been switched before printing. In this case, the MDM's reference coil was on the bottom and the sensing coil was on top. The only solution for the PCB itself was to cut and jump the copper traces to their respective coil with magnetic wire. However, as a result, the magnetic field was reduced over time due to the resonance frequency dropping below its required 1.3 GHz on the stacked coil. The stacked coil's resonance frequency now reads at 22 kHz. This may be due to magnetic wire being constantly reapplied when broken off the traces. Sadly, metal detection can no longer occur. However, the MDM still buzzes when a person's magnetic field comes into contact with the coils, since it is strong enough and close enough to create interference.